Good afternoon, friends, and welcome to another session of Parijat Sir classes. And today I will be dealing with you a mathematics topic, which, as you can see, that is probability. Okay, so this is a chapter which, if you do not know it in a proper way, then you will be having trouble in understanding the class 12 probability and the permutations and the combinations. Those you will be having a little bit of trouble. So today what I will do is that I will be doing this chapter right from the basics. So please keep following Parijat Sir classes and like, share and subscribe my channel so that I can make more of these type of videos for you. Now what the chapter probability is, it is a complete chapter of how the different type of things will be chosen from a given sample space. Okay, so without wasting any time, let us move ahead into the chapter. So first of all, before starting the chapter, there are certain things which you have to be little bit aware of so that it can help you. Okay, the first thing, see, not A. What does not A means? Not A. For example, if I draw here three circles, like this, and name them A, B and C. So please watch here. What does not A means? Not A would suggest that this is the portion which is not A. That means you will not choose this, you will choose only this portion, because you cannot choose A. This means not A. Clear? This means not A, and this is how you show it not A. Clear? First of all, it is clear. So let us see the second part. In the second part, first let me write it. This is the C. Okay, then we are having at least one of A or B. That means at least you should choose A or B or both. So it is A union B. It is A union B. And what is A union B in this? It is this portion. A union B is this portion. This is A, this is that A, and this is that B. A union B. So this means at least one of A or B. At least one of A or B means A union B. Clear? So next, let us see. The next part says A and B. A and B means A intersection B. A and B means A intersection B. So please note the word and or. If it is or, you will write A union B, and if it is and, you will write A intersection B. Now what is A intersection B? A intersection B is this part. This is the A intersection B. That means common to both A and B. This is called A intersection B. Okay, common to both A and B. Next, let us see the next thing. The next thing, A but not B. A but not B. So see, I need A but not B. So there is a complement, A but not B. So how to write it? So what is A but not B? That means this portion, this is called A but not B. This is the A but not B. So please watch here. This is that A but not B. That means you will choose A but no portion of B will come into this. Clear? Next, so the next thing is neither A nor B. That means I don't want A or B. So A complement intersection B complement. Neither A nor B. That means I don't want A or B. Either I don't want A or B. So what will be the portion? I don't want A or B. So neither A nor B is this portion. This is that portion which is neither A nor B. This is that portion which is neither A nor B. Clear? Next, the next part says at least one of A, B or C. That means at least you should have A or B or C or both A and B, B and C or A, B and C. That means this A union B union C. At least one of A, B or C. That means either A can come or B or C, or A and B can come or B and C can come, or all the three can come. So basically if you are choosing this, so A union B union C will be this portion. This is that A union B union C. This whole thing is A union B union C. Okay, so this is that A union B union C. Next, so if I now see the next part, exactly one of A and B, exactly one of A and B. That means either you have to have only A or only B. So see, you are taking A but not B, and you are also taking B but not A. You are taking A but not B. That means this part, you are taking this part A but not B. This is A but not B, and this is B but not A. This is the B but not A. So this is that portion you are choosing, B but not A. Clear? So next part, is all of three A, B and C. That means there should be A, there should be B, there should be C. So it's only one part is visible, that is this part. It is A, B and C. All three can come in this region. A, B and C. All three can come in this region. Clear? So next, friends, exactly two of A, B and C. That means you need any two of them but not the third. You need any two of them but not the third. You need any two of them but not the third. Okay, that means any two of them but not the third. So that means you need any two of them, this or this or this, but not the third. Okay, so middle one will not be the I'm sorry. Okay, so I need any two of them but not the third. So see here, I need A intersection B but not C. That means I need A intersection B, this part, but I don't need C. Or I need A intersection C, but I don't want B. I need B intersection C, but I don't want A. So these are the parts. So basically it was okay. Next, friends, let us see. So these are the basic things you have to have an idea before you start with probability. So let's see here. Next, only A occurs. I need only A occurs. So watch here, only A. I need only A. So which is only A? This is that only A. This is the only A occurs. And how to write it? This. That means I don't want B or C. So see, there is a complement over B and C. I don't want B or C. So there is a complement over B and C. Okay. Next, I need both A and B, but not C. I need both A and B. So see, A and B, I need both A and B, but not C. So this is my A and B I need, but C complement is there. Okay, I need both A and B, but not C. So this portion is that. A and B I need, but not C. Next, I need all of the three events. So when it is all of the three events, as you can see, this is that portion, this part, all of the three events, this is that portion. Clear? Next, I need at least one occurs. That means any one of them should occur. So at least one occurs. That means A union B union C. That means you can have at least either A or B or C, or two at a time or three at a time. That means this whole portion, this whole thing. Okay, this is that whole thing which we need. Clear? So next, one and no more occurs. That means you need only one, but no more occurs. So here is that. You need only this, or this, or this, and this. That means one and no more occurs. This is the fifth. This is the sixth one. Sorry, this one. That means you need any one of them, but the other two will not come. Other two will not come. You need any one, but other two will not come. That means this portion and this portion and this portion. So these, the two will not come. Okay, any two and the other one will not come. Next is, I need two and no more occurs. Two and no more occur. That means, see, there are two things selected. A intersection B, third is not there. B intersection C, third, A is not there. A intersection B, C, B is not there. That means any two will occur. So this or this or this. This is the thing. Next, none occurs. So I don't want any one of them to occur. None occurs. So see, this is A union B union C, complement of the whole. None occurs. That means outside this portion. Outside. You cannot shade any part. And that means next one is not more than two occurs. Not more than two occurs. So not more than two occurs is this part. That means more than two cannot occur. So see, this part is complement, this is complement, this is complement, not more than two. So any one of them can also not occur. Any one of them can also not occur. So these are the things. Clear? Now based on this, we will be moving ahead with the chapter, and let's see how to solve this type of numericals. Clear? So let's move ahead. Now, first of all, please understand there are two things. One is a mutually exclusive events. What is a mutually exclusive events? Mutually exclusive event means that if between two sets or three sets you don't have anything common, suppose between A intersection B, you see there is nothing common, so A and B are mutually exclusive. Between A and C there is nothing common. A and C there is something common. Between A and C, what is common? 6. 6 is common. 6 is common. So it is not mutually exclusive. Again, between A, B and C, what is common? Between A and B there is nothing common. Between B and C also, if I take between A and B there is nothing common I am getting. So nothing common with C is also nothing common. So between all the three there is no number which is common. So A, B and C are mutually exclusive events. But between B and C, see, there is a 3 common. Between B and C there is a 3 common. So B and C are not mutually exclusive events. And one more thing, please note, your probability will always, the value of the probability cannot exceed 1 and cannot be negative. Value of the probability cannot exceed 1 and cannot be negative. Clear? So let's move ahead. 3 coins are tossed once. So when you toss 3 coins, what is your sample space? Remember, one coin has 2 options. So if you toss it 3 times, there will be 8 options. So these are your 8 options. Okay. So these are your 8 options which can come when you toss 3 types of coins together. Now they are telling that you need all head. So all head is how many times? Only 1 time. So 1 out of 8. At least 2 heads. At least 2 heads. That means you can have 2 heads and 3 heads. So how many are there? That means you cannot take no head. You cannot take 1 head. You cannot take 1 head. Okay. So these are the options. These are the options. At least 2 head. So it is 4 out of 8 means 1 by 2. At most 2 heads. That means you can have 0 head, 1 head and 2 head. That means you have to leave the probability of 3 heads. So what is the total probability? Which is 1. From that we will leave the probability of 3 heads. So 3 heads there is only 1 time. So 1 minus 1 by 8 is 7 by 8. Next is no heads. No head, there is only 1 part. There is tail, tail, tail. So 1 by 8. Next is exactly 1 tail. So exactly 1 tail, how many times you are getting? 1, 2, 3. So 3 out of 8. Next is exactly 2 tails. So exactly 2 tails, how many are you getting? 1, 2, 3. So 3 out of 8. And last one is a head on the first coin. Head on the first coin. First coin should have a head. So which are the things you will be choosing? Number 1 is this. Head on the first coin. 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 And that's it. That means 1, 2, 3, 4. So 4 out of 8, which is half. This is your answer. Next, let us move ahead. A die is thrown. A die is thrown. Find the probability of getting an even number. So when you throw a die, please note, when you throw a die, these are the options. Okay. So an even number. So what are the even numbers? These are the even numbers. So 3 out of the 6. Next, prime number. So which are the prime number? These are the prime numbers. So 3 out of 6. Number greater than or equal to 3. equal to or greater than 3. So these are the options. So 4 out of 6. A number less than or equal to 4, less than 4 or equal to 4. These are the options. 4 out of 6. A number more than 6, there is no option, so probability is 0. A number less than or equal to 6, so all will come. Less than or equal to 6. So it will be 6 by 6 and the probability is 1. Clear? Next. Let's see friends, 2 dice are thrown simultaneously. Please remember, when you throw 2 dice, these are the options, which is 36 in total. These are the different options which you can create, and there are total 36 different possible ways. Okay, so there are total 36 different possible ways. Please remember, 36. Now they are asking an even number as the sum. That means out of these 36 options, you have to choose which are giving you even numbers. So see, these are the numbers, these are the options which can give me even number as a sum. 1 plus 1 gives you 2, 1 plus 3 gives you 4, 1 plus 5 gives you 6. All these, if you add these two, you should get an even number. So you will choose all these. And how many are there in total? We find there are 18 of them out of the 36. So 18 by 36, it is half. Second, they are asking the sum should be a prime number. So please watch. If I choose this 1 plus 2, it's a prime number 3. This will give me 5 prime number, 7 prime number, 3 prime number, 2 and 3 prime number. So how many of them I am getting here? How many of them I got here? 15 out of 36, which is 5 by 12. Next, a total of at least 10. That means 10, 11 and 12. The total should come 10, 11 or 12. So see, this is giving me 10, 10, 10, 12, 11, 11. So in total there are 6 options out of 36. So that is the answer, right? Next, they are asking us a doublet of even number. A doublet of an even number. So which are the doublets of an even number? So these are doublets but with only even numbers. Doublet means same number but only with even numbers. So you have got only 3 options out of 36, which is 1 by 12. Next, they are asking you a multiple of 2 on one die and a multiple of 3 on the other. That means the first number should be a multiple of 2 and the second number should be a multiple of 3. So let's see how many options are there. These are the things. First one multiple of 2, second one multiple of 3. First one multiple of 2 and multiple means one should have multiple of 2 and the second one should have multiple of 3. So these can be the options. Okay, that means one die should have a multiple of 2 and the other die should have the multiple of 3, like this. So it can be on the first die multiple of 2 and second die multiple of 3, or first die multiple of 3 and second die multiple of 2. In this way we are having 11 options out of 36. Next, same number on both die. So how many options are there? Same number on both die. So these are the options. Same number on both die, that means doublet. So there are 6 options and 6 by 36 is 1. And the last one was a multiple of 3 in the as the sum. It should be a multiple of 3. After adding, it should be a multiple of 3. So let's see how many options are there. This multiple of 3. The sum should be a multiple of 3. The sum should be a multiple of 3. So in total there are coming 12 such options out of 36, and that is the answer. Clear? Next question is, consider a leap year has 53 Sundays. That means you should have a leap year and there should be 53 Sundays. Now we know that leap year is 366 days. That means there are 52 weeks and 2 days. 52 weeks makes us 364 days. Okay, and in the 52 weeks we have 52 Sundays confirmed. And the next 2 days, so 52 weeks has 52 Sundays, but we need 53 Sundays. So the remaining 2 days can be of what options? It can be Sunday, Monday, it can be Monday, Tuesday, it can be Tuesday, Wednesday, it can be Wednesday, Thursday, it can be Thursday, Friday, it can be Friday, Saturday, it can be Saturday, Sunday. And out of these, see, already I have got 52 Sundays, but I need 53 Sundays. So out of these 2 days which are left, these can be the options of the 2 days. How many are Sundays? Here we are getting 1 Sunday and here we are getting 1 Sunday. That means out of these 7 options, there are 2 options which can give me Sunday, 1 more Sunday, so that I can have 53 Sundays. Out of the 7 options, there are 2 options which is giving me Sunday. So this is the answer of this. Next question. A coin is tossed. If the head comes up, a die is thrown. But if the tail comes up, the coin is tossed again. So let's see. If the head comes up, a die is thrown. So if you can have head with 1 or head with 2 or head with 3 or head with 4, head with 5, head with 6. Because if head comes, I will throw a die, and a die has 6 options. And if a tail comes, the coin is tossed again. That means you can have either head, tail with head or tail with tail. So this is my sample space. Basically, this is my sample space. Now they are asking us 2 tails. So only 1 option is there out of 8. Second, they are asking a head and a number 6. So this is that option, only 1. Then they are asking a head and an even number. So head and an even number, how many it can be? It can be this, it can be this, or it can be this. So 3 options out of 8. That is the answer. Next, they have given us the word assassination. Find the probability that the letter is a vowel or a consonant. That means you have to choose 1 letter out of this, and it should be a vowel. First of all, it has to be a vowel. So in the assassination, there are 13 letters. And in the 13 letters, how many are vowels? So these are the vowels. Any one of them I can choose. Okay. So, and the consonants are these. So total vowel is 1, 2, 3, 4, 5, 6. So any one of the 6 I can choose out of 13. And if I want to choose the consonant, 1, 2, 3, 4, 5, 6, 7. So any one of the 7 I can choose as a consonant. Next question, a 4-digit number greater than 5000 I have to form using these digits. Using these digits, I have to form a 4-digit number greater than 5000. How many numbers are there divisible by 5? And they are telling you can repeat the digits. You can make the numbers by repeating the digits, and the number should be greater than 5000. Mind it, number should be greater than 5000. Repetition allowed, and the numbers should be divisible by 5. So keeping this, let us see how to make it. So this is that 4-digit. You have to use the digits this. Okay, so first of all, remember it should be divisible by 5. So please remember one thing, okay, and you can repeat it. You can repeat it. Okay, so if you have to make a number greater than 5000, that means you have only two numbers, 5 and 7, which can come. So numbers starting with 5, okay, numbers starting with 5, you can repeat the digits. You can repeat the digits. How many digits are there? This number starting with 5, and that number should be divisible by 5 also. These two options we have to see. Okay, it should be greater than 5000 and it should be divisible by 5. So if it is divisible by 5, you know that the last digit, this, you have only two numbers which can make them greater than 5, that is 5 and 7. So in the first box there are two options. Okay, second, how many numbers will be greater than 5000? That is my main target. Greater than 5000. So the starting digit should be a number either 5 or more than 5. So two options. Now they are telling you can repeat any digit. So I have got total 5 numbers. So here I can put any one of the 5 digits. Any one of the 5 digits I can put, because they are telling repetition is allowed. In the third column, I can put any one of the 5 digits because repetition is allowed. And in the fourth, I can put any one of the 5 digits. Repetition is allowed. So total number greater than 5000, how many can I make? So 2 options into 5 options into 5 options into 5 options. 250 numbers can be greater than 5000. But I need how many numbers are divisible by 5. So here, first of all, out of these I know that here I can use only 2 options. That means either 5 or 7. So suppose I have used up so that means in this part I can make either with 5 or 7. Now please watch. Suppose if I use up 7, so in the next column I can have only 5 options, because divisible, they are railing, you can repeat the digits. You can repeat the digits. So you can have all the 5 options. You can put any number here. Here also you can put any number, 5 options. But here you want it divisible by 5. That means this should end by either 0 or by 5. So 2 options. So in total, how many numbers greater than 5000 and divisible by 5? There are 2 options in the first case, 5 options, second case, 5 options, third case, 2 options for the second case, 100. So the probability will be 100 by 250, which is 2 by 5. Now they are telling that you cannot repeat the digits. It should be greater than 5000 and divisible by 5, but you cannot repeat the digits. 4-digit number. Okay. So first of all, how many 5-digit number, how many 4-digit numbers can I make? Okay. So how many 4-digit numbers can I make greater than 5000? So as you can see that they are telling that if you are allowed to not to repeat the digits, but your number has to be greater than 5000, okay, and divisible by 5 also. So first of all, let us start that the first digit will start with 5, okay, and we are not allowed to make any repetition. So there will be only 4 options, 3 options and 2 options. So total how many? 4-digit number starting with 5 I can make 24. Now number starting with 7, so there will be only 1 option. And now out of the 5 digits only 4 options. Now out of the 5 digits only 3 options, out of the 5 digits only 2 options. This is actually starting with 7, so there is only one option. Starting with 5, one option. So 1 into 4 into 3 into 2, so there are 24 numbers starting with 7, 24 numbers starting with 5. So total numbers greater than 5000 is 48 numbers. Now my question is, how many of them will be divisible by 5? So for divisible by 5, you need that the last digit should end by 0. So one option, and you cannot repeat digits. So starting with 5, ending with 0, that means 2 digits you have already used up. So there will be 3 options here and 2 options here. So here you are starting with 5, so one option, ending with 0, one option. Now you are having 3 options here and 2 options here. So total you make 6 numbers. Next, starting with 7, so only one option, ending with 0, one option. Okay, so there will be 3 options and 2 options, so 6 numbers. Now is starting with 7 and ending with 5, so one option and one option. So there are 3 options left for this and 2 options left for this. So total 6. So total how many numbers I could make which are divisible by 5 is 18. And how many numbers greater than 5000 I made? 48. So my probability will be 18 by 48, which is 3 by 8. Clear? 3 by 8. Next, one card is drawn from a pack of 52 cards. Find the probability of drawing an ace. Okay, first of all, see, we know 52 cards, so there are 2 of red suit, 2 of black suit. The red suits are called heart and diamond. In that heart you have a king, a queen, a ace and jack. You have a king, queen, ace and jack. In the clubs and spade, which are black colored cards, you also have a king, queen, ace and jack, and here king, queen, ace and jack. And now see, these king, queen, ace are called face cards. So in total there are 3, 3, 6, 3, 9, 3, 12. So 12 face cards are there, and everywhere there is a king, queen and ace and jack, and the others are numbered cards from 1 to 9. So this is the 52 cards. Now they are telling you want an ace. So see, there are total 4 aces, as you can see here. There are total 4 aces in every suit, 1 ace. So in total there are 4 aces. So the answer will be 4 by 52, which is 1 by 13. Second, they are asking red card. So how many red cards are there? 26. So it will be 26 by 52, which is half. Next, they are telling either red or king. You can have either red, which is 26 cards, or a king. Now in the red already you have chosen the king. So in the 26 red card, there are 26 red card, and you can have or king also. So only 2 more kings black colored are left. That means the total red cards are 26 and 2 kings I have to take from the black, because already 2 red kings are taken here. So total 26 plus 2, 28 by 52, which is 7 by 13. Next is a red and a king. It should be a red and it should be a king. So I know that in the red there are only 2 kings. So it will be 2 by 52. This is that answer. Next, an urn contains 7 red, 9 red, 7 white and 4 black. So total there are 20 balls. You have to draw 2 balls out of the 20. And what is the probability that both the balls are red? That means 2 balls you are drawing out of 20. How many ways you can draw 2 balls? This is the way. And those 2 balls has to be red. So out of the 9 red balls, how many ways can you draw 2 red balls? This is the way. So probability, this is the total sample space and this is what you require. So please watch one thing. NCR is actually n factorial by r factorial into n minus r factorial. Okay, so 9C2, how can I write 9 factorial by 2 factorial into 9 minus 2, 7 factorial. Similarly, 20C2 is 20 factorial by 2 factorial into 18 factorial. So please watch one thing, 2 factorial cuts. It is this. And now 9 factorial, I can write 9 into 8 into 7 factorial, which is cutting. 20 factorial, I can write 20 into 19 into 18 factorial. This 18 factorial cuts. So remaining is this, which is 18 by 95. And now they are telling one ball is white. Okay, you have to find out one ball should be white. You are drawing how many balls? You are drawing 2 balls. From the 20 balls, you will draw 2 balls and one should be a white. So white there are 7. So out of 7 you need 1. So remaining there are 9 and 4, 13. So 13 I should draw any one ball. And this is from the 20 I need 2 balls. From 20 total sample space is from 20 I need 2 balls and one ball should be red, should be a white, and the other ball can be anything. That means red or it can be a black. So total from 13 I need 1. And when you solve this, you get this answer. Similarly, the balls are of the same color. That means both the balls can be either red. So you can write like this. Out of the 2 balls drawn from 20, the 2 balls can be red, or the 2 balls can be white, or the 2 balls can be black. So this is the answer. One is white, one is red. So how to draw one white ball? Out of the 7, 1 is white, and out of the 9 red, 1 is white, and this is the total. Out of 20 you are drawing 2 balls. So that is the answer. Next is, in a lottery of 50 tickets, the tickets are numbered 1 to 50. 2 tickets are drawn. That means from 50 tickets you will draw 2 tickets. What is the probability both tickets are prime numbers? So how many prime numbers are there? These are the prime numbers. So in total there are 15 prime numbers. So from 15 I have to draw 2. So this is how I will draw. And what is the total sample space? From 50 tickets I have to draw 2 tickets. And those 2 tickets should be prime numbers. So this. Next, none of the tickets are prime. If none of the tickets are prime numbers, that means, okay, here I have not done it. So the second option, this is the third option actually. The second option will be none of the tickets are prime numbers. So it will be 1 minus 15C2 by 50C2. That is the answer of the second one. One ticket is a prime number and the other one is not a prime. So from 15 prime numbers I will choose one, and from the rest 35 numbers I will choose another number, another ticket. So this is out of total 50 tickets. That is the answer of the third part. Next, a bag contains 10 bulbs, of which 3 are defective. So 3 defective, so 7 are good bulbs. 5 bulbs are drawn from 10 bulbs. Exactly 1 defective bulb. I need 1 defective bulb and 4 good bulbs. So if I need 1 defective bulb from 3 bulbs, so I have to draw it like this. And total I will draw how many bulbs? 5. Okay, so 1 is defective and the 4 should be good ones. So from 7 good bulbs I will draw 4 bulbs like this. Out of the 10 bulbs I have to draw 5 bulbs like this. Okay. Next they are telling exactly 2 defective bulbs. So from 3 defective bulbs I will draw 2 defective bulbs like this. So 2 bulbs already drawn. Now I need 3 more bulbs out of the good bulbs. So from 7 good bulbs I need 3 good bulbs. This is my total. I need out of 10, 5 bulbs are drawn like this. No defective bulbs. That means all the 5 are good bulbs. So from the 7 bulbs, good bulbs, I will take 5 good bulbs out of this sample space. Next, a bag contains tickets from 1 to 30. So there are 30 tickets. 3 tickets are drawn. 3 tickets will be drawn. What is the probability that maximum number of selected tickets exceed 25? So please watch one thing. I will draw 3 tickets. Maximum tickets will exceed 25. That means out of the 3 tickets, the 2 tickets should be greater than 25 and that 1 ticket should be less than 25. Clear? So how many numbers are more than 25? How many numbers are more than 25? So it is only 5 numbers which are more than 25. Okay. So 2 tickets should exceed 25. What is the problem? Maximum number. Okay. Maximum number of tickets should exceed 25. That means 2 tickets can exceed 25 or 3 tickets can exceed 25. Okay, they told maximum number of tickets should exceed 25. So either 2 tickets can exceed 25 or 3 tickets can exceed 25. So how will you find 2 tickets exceeding 25? It is first find out the number of tickets less than 25. Probability of number of tickets less than 25. Okay, so how will you find out this less than 25? 25C3 by 30C3 and then 1 minus this will give you the answer. Now if all the tickets are exceeding 35, so 25C3 by 30C3, all the tickets are exceeding 25. So these are the options. All the tickets are exceeding 25. Right? That means if I can find out the number of tickets which are 1 ticket less than 25. Okay, so it will give me 2 tickets more than 25 or 3 tickets more than 25. So basically if I do how many 1 tickets less than 25. Okay, so this is the way. If I subtract that 3 tickets. If I subtract this option that all the 3 tickets are less than 25 from the total probability of 1, if I subtract the probability of getting all the 3 tickets less than 25, I will get my answer. Okay. From the total probability, if I subtract how many all the 3 tickets are less than 25, then I will get the answer that 2 tickets can be more than 25 and 3 tickets can be more than 25. Next, friends, find the probability that birthdays of 6 different persons will fall in exactly 2 calendar months. Please watch the sum. Birthdays, find the probability that birthdays of 6 different persons. So there are 6 different persons, and I want their birthdays should fall in 2 calendar months. So watch here, there are 12 months. Out of the 12 months, so watch here please, total probability that the first person can have any one of these 12 months as his birthday. The second person can also have any one of these 12 months as his birthday. The third person can also have any one of these. So first person can have 12 options for his birthday. Second person can have 12 options for his birthday. Third person can have 12 options for his birthday. Fourth person can have 12 options for his birthday. Fifth person can have 12 options for his birthday. And sixth person can also have 12 options for his birthday. That means in this way they can choose their month of the birthdays, 12 to the power 6. Now out of these 12 months, we are wanting that any 2 months, so any 2 months can be chosen in this way. Out of 12, any 2 months can be chosen into this way. That now the 2 months are decided. So the first person can have 2 options, second person can have 2 options, third person can have 2 options. That means the fourth person can have 2 options, the fifth person can have 2 options, the sixth person can have 2 options, because I want all of the person's birthdays should fall on those 2 months. So there are total 2 to the power 6 ways in which the 6 persons can have the birthdays chosen. Okay, now in that case what will happen? First I have chosen 2 months, and then I have chosen that the total options for the birthdays will be in the 2 months will be 2 to the power 6. But please remember that from these there can be an option in which all the persons can have the birthday in the same month. So that option has to be removed. Suppose all the persons have their birthday in that single month, so I have to remove that option. So out, this is the total sample space. So this is the total ways in which all the birthdays, all the 6 persons can have birthdays in 2 calendar months. Okay. Next sum, friends, let us see. In a single throw of 3 dice, please note that if you throw 3 dice, the total sample space is 216. Total sample space, because it is 6 to the power 3. If you throw it 2 times, it will be 6 to the power 2, 36. If you throw it 3 times, the total sample space will be 216. I want a total of 5. Okay, we are throwing 3 dice. So in the 3 dice, how many ways you can get 5? It can be 113, it can be 131, 311, 122, 221, 212. So that means there are total 6 options in which you can get a total of 5. So 6 by 216 is the answer. Next, I want a total of at most 5. That means not more than 5. So not more than 5, what are the options I can have? I can have 3, 4, 4, 4, 5, not more than 5. So 5 I can have 5, 5, 5, 5 and 5. So these are the only options which I can have of at most a total of 5. That means 10 out of 216, and that is the answer. Next, they are telling a total of at least 5. At least it should be 5. So at least 5 means you can have minimum 3 or 4, 4, 4. Okay. So these are the options in which have you have less than 5. So how many are there which are less than 5? 4. But I need at least 5. That means from the total, if I subtract the options which give me total of 4, I can get at least 5. Okay. I am subtracting out from the total probability 1. I am subtracting how many can give me less than 5. So automatic I will have at least a total of 5. I will have at least a total of 5. Next, the letters of the word society. So there is a word called society, SOCITY, are placed at random. What is the probability that the 3 vowels are together? So how many vowels are there? There are 7 letters in total. There are 7 letters. So as we can see here that the word society, it has how many letters? It has got 7 letters with us, and then in that there are 3 vowels. So I want 3 vowels to be together. So let us keep all the 3 vowels together in one box and name it X. So then in total how many are we are having? S, C, T, Y and X. Okay, so there are 5 letters now. So wherever I put this letter X, I know that inside it there are 3 vowels. So X, wherever I put now, the X which carries 3 vowels will always be together. So in how many ways these 5 letters can be arranged? Factorial 5 ways. And in that factorial 5 there are 3 letters which also can be interchanged. These also can be interchanged. They can be interchanged. Okay, they can be interchanged. So in how many ways can I interchange them? 3 factorial ways. So that 5 factorial into 3 factorial out of the total 7 factorial, and that is the answer. Next is, there is the word university, and I want 2 I's should come together. Okay, so the university has 10 letters. They can be arranged in 10 factorial ways. Now the 2 I's, I can make it into one box. So it makes us total 9 letters which can be arranged in 9 factorial ways. So in this 9 factorial ways, the 2 I's, since it is common, see the letter I, please watch here, the letter I, they cannot be interchanged because it will mean the same thing. They cannot be interchanged. So when the letters are of same type, then you have to write it 9 factorial by 2 factorial out of the total 10 factorial. 9 factorial by 2 factorial. And here what did I do? The letters were different. O, I, E were different. So when you have different letters, then you have to do into 3 factorial. And when you have the same letter, then you have to do by how many letters are getting repeated. By. So please note the difference between this and this. So when the letters in a box are different, you have to do into 3 factorial, into that factorial. And when the letters are same, then you have to do by how many letters are same. Next, so we have to make a 5-digit number using the digits this without repetition. Find the probability that the number is divisible by 4. Please watch. I cannot repeat the numbers. So in how many ways I can make a 4-digit number? In how many ways I can make a 4-digit number? It is, so please watch one thing. That means in total, how many ways can I make a 4-digit number without repetition? So in the first box, I can put any one of the 5 options, then 4 box, in the next box 4 options, in the next box 3 options, in the next box 2 options, and in the next box 1 option. So it is a 120 total numbers I can form. Out of this, how many will be divisible by 4? So for the divisibility rule, your last digit should be having the last 2 digits, because it is 4, the last 2 digits should have the number which is divisible by 4. That means the last 2 digits should have either 12 or 24 or 32 or 52. Okay. Now when we have 12, that means 2 options are already chosen. Out of the numbers 1, 2, 3, 4, 5, I have already chosen 2 numbers, 12. That means in the first box I have 3 options, in the second box I have 2 options, third box I have 1 option. That means total 6 numbers. When I make the last 2 digits 24, again I have got first box 3 options, then 2 options, then 1 option. So it is 6 numbers. When I make the last 2 digits 32, so again in the first box I have got 3 options, 2 options, 1 options. That means 6. And when I make the last 2 digits 52 as fixed, in the first box I have got 3 options, then 2 options, then 1 option. So 6. So there are total 24 numbers which are divisible, 5-digit number divisible by 4 out of the 120. So this is my probability, and the answer is this. Next. Now friends, please watch one thing. Already I have shown you that it is the Venn diagram parts, and how to deal with this. So the first formula, if I need P A union B, between A and B, if I need P A union B, that means what will come? The formula is PA plus PB minus PA intersection B. This is that A intersection B. This is A intersection B. And if A and B are mutually exclusive, that means there will be nothing common between A and B. So this will be the answer. If they are mutually exclusive, this will be the answer. Similarly, if I need PA union B union C, I have to write PA plus PB plus PC. So please note here, this formula is very, very important. We will require it many times while doing the probability sums. This is that formula for PA intersection B, and there are 3 sets. Then this is our formula PA plus PB plus PC minus PA intersection B minus PB intersection C minus PA intersection C plus PA intersection B intersection C. This is the formula for us. Similarly, if I need PA complement intersection B, that means I don't want A. So what is the common with PA complement? That means PB minus PA intersection B. If I need PA intersection B complement, B, so from PA I will subtract out the PA intersection B. If I need PA intersection B complement union PA complement intersection B, So I will add these two and I will get this answer. PA or B means PA union B, and PA and B means PA intersection B. So these are the things which you have to note very carefully before doing the subs. So let us proceed ahead with the numericals. So the first numerical says PA is given 1 by 4, PA is given 1 by 4, PB is given 2 by 5, and PA union B is given this. Find PA intersection B. So using this formula, we know PA A union B. We know PA union B is given to us. PA given, PB given, PA intersection B not given. So this is the answer. Next, I want PA intersection B complement. That means from PA subtract the PA intersection B. So PA already I know, and intersection we just now found. So that is the answer. Similarly, PE given, PF given, PA and E, that means PE intersection F given. Find PA or F. E or F means PE union F. Please note PE or F, already I told you. E or F means PE or F. It means P union F. It means P union F. And P union F, already formula we know. So putting the values whatever we know, we get the answer. Similarly, PE complement minus F complement. That means from this will be what? PE complement minus F complement, intersection F complement is 1 minus PE union F. So E union F, already we know that, and we get the answer. E complement minus F complement is this answer. Next, P not E not F, P not E or not F is given. P not E or not F is given to us. Whose formula is this? So basically, if you see here, if it is P not E or not F, it is given here 0.25, as you can see here. State whether E and F are mutually exclusive or not. Okay, so please note, mutually exclusive only it will be if P intersection F comes 0. If P intersection F comes null set, then only it will be a mutually exclusive. So let's see that. This is given P not E, so E complement, not F, so F complement is given, which is actually 1 minus PE intersection F, which is given this. So P intersection F is coming 0.75, which is not a null set, so it is mutually exclusive. That means there is something common between the two, E and F. A, B, C are three mutually exclusive and exhaustive associated events. Okay, so mutually exclusive, that means A, B, C are mutually exclusive events. That means P A intersection B, P B intersection C, P A intersection C should be a null set, because they told it is a mutually exclusive. Okay, and for exhaustive events, please watch one thing: P A union B union C should be P A plus P B plus P C. This is very important. This is very important, that for X, if it is exhaustive events, then this is how what I will write. This is how what I will write. Now we will replace here PA PB is given 3 by 2 PA and PC is given half PB. So in place of PB I will write 3 by 2 PA. So solving this we get PA as this. They told find PA. Next, find the probability of getting an even number on the first die. So what are the things we have to do? Even number on the first die. So this is, let PA be even number on the first die. So these are the options which is giving you even number on the first die. Please note here, first die will have even number. These are the options. Okay. Next they are telling total of 8. So there are two things. Even number on the first die is first job. Second job is total of 8. Okay, in a single throw of 2 die. Total of 8, how will I get? Total of 8, sum of 8. These are the options. Okay, so here what I can see that between the two PA and PB, there is something common coming. What? These are the common things coming. Here you see 2 6 2 6 6 2. Here is 6 2 6 2. Then is 4 4 and 4 4. These are the options which are coming common. Okay, so PA union B is PA plus PB minus PA intersection B. So what is PA? 18 by 36. There are total 18. What is PB? 5 by 36. What is PA intersection B? 3 by 36. So putting here we get 5 by 4 9 as the option. Next is a die is thrown twice. That means there are total 36 options. What is the probability that at least one of the two throws comes up with a number 4? One of the two throws. That means one throw will be there coming with a 4. So let us see. First die comes 4. So these are the options. Second die comes 4. So these are the options. And both die between the two common, both die come 4. So these are the probabilities, and if I use PA union B, PA is coming this, PB is coming this, PA intersection B is coming this. Solving it, we get this is the answer. Next, one number is chosen from 1 to 200. So from 1 to 200 I have to choose one number, only one number. Okay. Find the probability that it is divisible by 4 or 6. That means I have to find how many are divisible by 4. So how many are divisible by 4? So these are the numbers divisible by 4. Then divisible by 6. And then divisible by 4 and 6. Common. So these are divisible by 4 and 6 which are coming common. So see, there is 12 and there can be numbers like 24, 36. So PA is coming 50 out of 200. There are 50 numbers from 4 to 200. If I 4, 8, 12, 16, there are 50 numbers. How did I get this 50 numbers? How did I get 33 numbers? So please watch here. 4, 8, 12, 16, dot, 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 200. So this is an AP series where the last number is 200. So 200 is equal to A plus n minus 1 and the D is 4. So 200 is equal to 4 minus it will come 4n. So n is coming 50. Similarly, for others also you can find how did I get 33, how did I get this 33, please note, how did I get this 33, how did I get this 16. This is the way you will be solving it, and you can find out the number. Okay, so this is how we get the probabilities. Now A union B will be this, putting the values we get the answer. Similarly, a card is drawn from a pack of 52 cards. Find the probability of getting a king. First job is getting a king, second job is getting a heart, and then common between the two. So PA, which is king, so there are 4 kings. PB, which is a heart, so there are 13 hearts. And red card, okay, the third job is red card. Red card, so you have to find the common between this. So the third job is to red card. So red card, there are 26. Now king of hearts, PA intersection B, king of heart is how many? There are only 1 king of heart. Similarly, heart of the red color, how many? There are 13 heart of the red color. Similarly, king of the red card, how many? There are 2 king of the red card. And all the 3 common, that means it should be a king from heart and it should be a red color. It is only 1 by 52. So using this formula, PA plus PB plus PC, the formula we know, and now putting the values, this is PA, PB, PC, PA intersection B, PB intersection C, PA intersection C, and plus PA intersection B intersection C. We are getting 7 by 13. So you have to create that common between any one of them, common between all the 3, all you have to find out. If there are 3 things, you have to find all these, whatever are highlighted here. You have to find if there are 3 jobs to be done, so you have to find these and then put it in the formula. Next, so the next sum says an integer is chosen from 1 to 50. What is the probability that the integer is a multiple of 2? So there are 3 jobs: multiple of 2, multiple of 3, or multiple of 10. So multiple of 2, so these are the numbers which are multiple of 2, and I can find that it is about 25 numbers. So 25 by 50. Multiple of 3, so these are the numbers which are multiple of 3. So I can see there are 16 of them. Multiple of 10, so there are 5 of them. Multiple of 2 and 3. 2 and 3, so there are 8 of them. Multiple of 3 and 10, so it is 1 only. And multiple of 2 and 10, it is 5 out of 50. And multiple of 2, 3 and 10 is 1 by 50. Now putting it here, because we have got 3 jobs to do, so this is the formula and we get the answer. Next is 2 dice are thrown, so there are 36 options. Probability that the sum of the number on the faces is neither divisible by 3 nor by 4. So it should not be divisible by 3. Okay, it should not be divisible by 3. So let us first find out divisible by 3. After that we will find out not. So divisible by sum of the numbers divisible by 3, so it can be 1, 2, 2, 1, 1, 5 because it is 6, This 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 is 9, 9, 12, 9, 9. So there are in total 12 numbers. So 12 out of 36 numbers are divisible by, whose sum is divisible by 3. Divisible by 4. So see, this gives you 4, 4, 4, 8, 8, 8, 8, 8, 12. So how many are there? 9. So there are 9 of them which is divisible by 4, and divisible by both 3 and 4, which is this, is 1 by 36. So how many numbers which are divisible by 3, 4 or both? It is using this formula we get this answer. But I want are not divisible by 3 or 4. So 1 minus that. 1 minus that is the answer. I don't want divisible by 3 or 4. So first I will find divisible by 3 or 4, and then I will subtract from 1. Next, 2 cards are drawn from a pack of 52 cards. What is the probability that either both are red? Both are red. So first job is both are red. So total red is 26. So 2 cards will be drawn from 26 cards. Out of 52 cards we will draw 2 cards. So this is the option. Both are kings. Both the cards, 2 cards, both the 2 cards should be kings. So how to draw? There are this, okay, so kings, 4 kings. From 4 kings I will draw 2 cards like this by the total sample space, and it should be a red king. And now red king, so there are 2 red kings and I have to draw 2 cards. So 2 by 2, 2c2 out of the total. Okay, so then we will find P A union B, and solving these we get the answers. This is the answer. The probability that a person will get an electric contact, he will get the contract PA, will be this. Not get the plumbing contract, that means PB not is this. So if he does not get the plumbing contract, what is the probability of getting the plumbing contract? 1 minus PB bar, 3 by 7. If the probability of getting at least one contract is 2 by 3, at least one contract, that means it is PA union B given, which is PA plus PB minus PA intersection B. They are telling what is the probability that he will get both. That means A intersection B probability, this is being asked. So we can find out. Next, a box contains 6 red, 4 white and 5 black balls. A person will take out 4 balls. So in total there are 6 plus 4, 10 plus 15. From 15 he will take out 4 balls. From 15 he will take out 4 balls. Find the probability that among the balls there is at least 1 ball of each color. At least 1 ball of each color. So it can be 1 ball. At least 1 ball should be of each color. So what I can do, I can have 2 red, 1 white, 1 black. And how to find the probability of this? 2 red out of 6, 1 white out of 4, 1 black out of 4. From the total 15, I will draw 4. This is how I will find. Similarly, 1 red, 2 white, 1 black. You should have at least one of them. So first here I am making red 2, then I will make white 2, then I will make black 2. So this is how you will find out red 1, from 6 red 1 ball, from 4 white 2 balls, from 5 black 1 ball. Out of 15 balls you will choose 4 balls. Now I want 1 red, 1 white and 2 black out of 15 balls. So now add all of them, because it is P, you add all of them. I want either this, they are all mutually, please note here, PA, PB and PC are mutually exclusive events. That means no event has got anything to do with the other. So I can write P A intersection B, P B intersection C, P A intersection C and P A intersection B intersection C should all give me 0. So P A union B union C should be only PA plus PB plus PC. So we will add all the 3 options and we get the answer. Next is Hamid will pass in maths, probability is 2/3, and in English it is 4/9. What is the probability that he passes in both the courses is given? What is the probability Hamid will pass in at least one subject? That means they are asking maths union English. So this is what they are asking: maths given, English given, and intersect both given. This they are asking using the formula. We get this answer. Next, find the probability of at most 2 tails. That means you can have at most 2 tails or 2 heads. So when you are tossing 3 coins, you are tossing 3 coins. So there are 3 coins, means total 8 options. So these are your 8 options. This is the main sample space. Now what do we want? I want to choose at most 2 tails. That means 2 tails or more than 2 tails. So it is coming 7/8. 2 heads. At most 2 tails or at most 2 heads. So 2 heads or more than 2 heads is coming 4/8. And what is the common between the two? These. The common between the two is coming this. First of all, this is common. Second, this is common. Third, this is common. Fourth, this is common. So there are 4 options out of the 8. So putting this formula, we get the answer. Next, friends, Anil and Ashima appear in an examination. Anil will qualify. This is the qualifying probability of Anil, qualifying probability of Ashima. And both will qualify is this. So see, qualifying for Anil is given, qualifying for Ashima is given, and both qualify is given. They are asking both will not qualify the exam. That means first find out both will qualify. This is both qualifying the exam. Okay. Now I want both will not qualify. So this is what I have to find. So 1 minus P A union B. This is the answer. At least one of them will qualify, or both can qualify. Either this, both will not qualify is this. So both will qualify will be this. 1 minus both not 1 minus both qualifying. 1 minus both qualifying will give you either one of them will qualify. Only one of them will qualify. Only one. So this is only A will qualify, that means only Anil, and this is only Ashima qualifies. So putting the values, this is the answer. So friends, with this we complete the complete probability. We finish the full probability of the class 11. This is the class 11 probability we have finished, and I hope you have understood. I have shown you from the basics. So my request is, please go through the video very carefully, pause and do along with me. Okay, note down all the formula list, whatever is there, and then try to understand and do with me. Then only you will be able to do it properly. Okay, so with that we complete this chapter. And again, it's a request from my side, as you are watching Parijat sir classes. You are watching Parijat sir classes, so please like, share and subscribe my channel definitely, so that I can make more and more videos for you. Okay, so it's all from my side now. So thank you so much.